Hi, I'm Joel Adams. This is about Crayowulf, a multidisciplinary senior capstone project. The problem is that we need capstone projects for our seniors, and so this project combines ideas from Cray supercomputers, specifically the Cray 1, and Beowulf clusters, specifically Wiglaf, the first one from 1994, into a mini Beowulf cluster we call Crayowulf. The goals are to build a distributed multiprocessor that takes features from the Cray, features from the Beowulf, has a single power cord, modern ports, and small enough to be portable for about $2,000. So you take a Cray 1, Seymour Cray here from 1994, and a Beowulf cluster like Wiglaf, the first one, combine these together, what do you get? Our idea was to take, here's our initial whiteboard sketch, and build a Cray-like cylindrical tower with a skirt and flower petal design so that the sides fold down and let you get at the insides, and whatever intake and exhaust vents and I/O ports we needed in addition. We had a multidisciplinary team of 2 mechanical engineering students, 1 pure CS student, and 1 CS plus electrical engineering double major. 1 mechanical engineering student built CAD design for the enclosure, and you can see the results here. And when he took that CAD design and then actually fabricated it out of aluminum, here is the result. And then we 3D printed vent grills to go in some of the holes in the enclosure. For node hardware, we chose the NVIDIA Jetson TX2 single board computer, which has 6 normal cores per CPU and a 206 CUDA core GPU, plus onboard gigabit Ethernet. The interconnect then was a gigabit Ethernet interconnect with a 16-port switch in the middle and an extra adapter on each board to avoid being network bound, and extra ports on the head node as well for communication to the outside world. We had a liquid cooling loop to imitate the Cray's liquid cooling system, and in order to implement that, Noah had to build custom water blocks to handle that coolant and cool off each single board computer. And then here's a picture of the resulting system, and we'll do a quick tour so you can see it in action. That's worker node 4 that we just opened up, and now you're going to see worker node 3. And then we go past the reservoir for the coolant, which uses deionized water, to worker node 2. Worker node 1. And last, the head node, which has a bigger multi-port network card to handle all the traffic it takes. If we zoom into the worker node here, you can see the water block and the coolant flowing through it to keep the thing cool. Under the skirt, we have the power supply, the switch, the network switch, and the hard disk these all share. And then it's actually running at the moment, running a browser and some BOINC clients. And if we close the thing up, then the lights are not just for eye candy. They attract student interest. We keep this thing in a window in a closed room. Students get curious, what is that thing? And ask us. We talk about parallel computing, can take them in. Prospective students are interested in looking at this thing. It makes the parallelism visible to someone who looks at it. And we pull back here, we can see the whole system in operation. All right, we'll stop there and go on. The cooling system keeps it about 9 degrees cooler centigrade than an air cooling system. And we'll stop there and just say, for more information, go to the project website or send email to me, adams@calvin.edu. And thank you and everyone involved for listening.